Hello and welcome to the A&P 2 lecture on the urinary system. Okay, so this video will complement the text and the notes that have been posted to D2L, so you're going to have to read the text and those accompanying notes that I provided for you. If you wish to go and collect some news or some of those notes that I gave you to follow this lecture, follow this video lecture, we shall pause right now and wait for you to come back. Okay, welcome back. The kidneys are located between the T12 and the L3 vertebra. They're partially protected by ribs 11 and 12, which are the floating ribs. So the kidneys are roughly the size of a fist. And they're retroperitoneal, which means they are behind the peritoneal cavity here. You can see here's the peritoneum, and here are the kidneys in the small of your back, and they kind of face in sideways. They're not very flat. So we can look in here and see that the right kidney is pushed down a little bit by the liver, although it doesn't look right in this specimen. This kidney would be down here. Going back and look at that one, yeah, it's not very good. In any event, the right kidney is going to be lower in the body than because of the liver pushing down on it, so it sits slightly lower. So in the middle of each kidney we have an area called the hilum, the renal hilum. This is that dent in a bean, any bean, kidney bean, pinto bean, there's always a dent in the middle of the bean. Is called the renal hilum. This is the entry point for the ureter, the renal artery, the renal vein, lymphatics, and some nerves that come in and out of the kidney. You can see that there's not much connecting this kidney. That's why it's one of the most easily to transplant organs in your body. The surgeon just has to snip 3 or 4 vessels right here, clamp them off, and out it comes. It's also very easy to have your kidney stolen when you go on vacation in certain countries where they harvest people's organs in hotel rooms. You may wake up someday with a big band-aid on your back and find out, whoops, you don't have a kidney anymore. They did that in 10 minutes. Okay. So the kidney is surrounded by, there's just another portion of showing you the areas. Here's the hilum, and here are the vessels and connections that come into that. That's all there is right here. Okay. So the kidney is surrounded by 3 layers of tissue. On the outside we have the renal fascia. It's a thin layer of connective tissue that anchors the kidney to its surroundings. And then we have the middle layer called adipose tissue, which is actually there to protect the kidney from trauma. It's called perirenal fat. Okay? The deepest layer is called the renal capsule, and that would be around the organ itself. A smooth, transparent sheet of dense connective tissue that gives the kidney its distinctive shape. If you take a cross-section of the kidney, there are 2 main parts. The inner portion is called the renal medulla. See the medulla here? This area in here is called the renal medulla, or the medullary area. The outside rim is called the cortex. The renal cortex covers this. Out here you may recall that cortex means bark, like the bark of a tree. So here's the cortex. The medullary area, or the medulla, is made up of 8 to 12 structures we call the renal pyramids. These guys are renal pyramids. They're kind of shaped somewhat like a pyramid, but there they are. Okay? So the base of these pyramids will face the renal cortex. Here's the base, and it's pointing to the cortex, base, cortex. They're pointing to the renal cortex. The tips of the pyramids, we call those renal papilla. Papilla, which means pimple, or little point. It's pointing that way. Okay. So it points towards the center of the kidney. The renal papilla project into things we call the minor calyx. The minor calyx is that collection area just after the papilla on the tip of the pyramids. Each one as a minor calyx area. Okay? And that projects to form the major calyxes. Here are the major calyxes. That's the area just below these. Okay? And they're all going to funnel into an area we call the renal pelvis. You can't see it well in this view here, but we have minor calyx that empty into major calyx that empty into the renal pelvis, which then empty into the ureter and out of the kidney. So 1, 2, 3, out. Okay, so there are also sections of the cortex we call the renal columns. The columns are the areas that separate the renal pyramids from each other. So we have a pyramid, we have an area in between the renal pyramids, which are called the renal columns, okay? It keeps them separated. So each renal pyramid and the renal cortex above it, this pyramid here, those areas together are called lobes. Okay, it's a renal lobe. So this would be considered lobe, and this one would be considered lobe, and this is considered lobe. Okay? So to reach the kidneys, let's take a look at another shot here. Here's another view of the renal capsule. Here you can see the major calyx. Okay, the minor calyx is this tube that's emptying into this area called the major calyx, which empties into this area we call the renal pelvis, the final collection area, and then out the ureter. Okay? The renal papilla is the point at the tip of the pyramid. Renal pyramid, again, you can see that this is the medullary area. This is a very good illustration you'll find in your notes that's very, very detailed. Here's the pyramid. This area here is the cortex. Okay. The papillae are the end of the pyramids. Okay. We have the renal column, which is between the pyramids. And the major calyx emptying from the minors. And they're emptying into the renal pelvis, which then goes out the ureter. And we'll talk about all these blood vessels in a moment. Okay. So to reach the kidneys, blood flows from the aorta into the left and right renal arteries. Okay, here's the renal artery. So these renal arteries enter the kidney and divide into segmental arteries right here. First branching is the segmental artery. Then into we need another shot here. There's an interlobal artery with this guy going up through the column in the lobe. Remember we said this is a lobe. So an interlobal artery which passes through the renal column. And then there's something up here called the arcuate artery. We'll go back over this one. So it's the artery that kind of runs along the edge here. The arcuate artery. They go over the bases of the renal pyramids, and then they're going to go into what we call the cortical radiate artery, which is these little fine guys up here, and they radiate out into the cortex. They supply all the blood supply to the cortex right here. Okay? So these cortical radiate arteries continue to divide, eventually forming something we call the afferent arterioles. And that splits into another tiny bundle of capillaries known as the glomerulus. Let's look at the blood flow first of all. Again, we have the aorta to the renal artery, to the segmental artery, to the interlobal artery, through the arcuate artery, into the cortical radiate artery up in the top of the cortex, into the afferent arteriole, through the glomerulus, bowl of capillaries, out through the efferent arteriole, and back into the peritubular capillaries and out through the venous system, emptying into the interior vena cava. All right. So the glomerulus is this guy here. Is basically a tuft or a ball of capillaries that filters things. This is where filtration actually starts. Okay. So blood comes in through the afferent, incoming arteriole, goes through this ball of tuft of capillaries, sifting solute, small things out, and what's not filtered out continues along as blood and is transferred to these cortical capillaries that kind of go around all these tubes, which we'll talk about, and then eventually out the afferent vessels. Okay? With each kidney, there are about 1 million nephrons. This guy here is known as a nephron. Millions of them in each kidney. It's made up of a renal corpuscle and a renal tubule. This guy is the renal tubule. So the renal corpuscle is where the blood filtration starts. It includes the glomerulus. Glomerulus is that tuft of capillaries inside this corpuscle. And Bowman's capsule, which is made up of renal cells that surround the glomerulus. You can see it here. Here's the afferent artery coming into the glomerulus, going through the tufts of capillary beds, and then coming back out again in the efferent. In the meantime, all this stuff that's being filtered out of your blood ends up through the loop system and ends up coming out as urine. Okay. Here's a close picture of it. As blood flows into the glomerulus, as it's incoming, and here's all the tufts of capillaries here. Water and some solutes in the blood, like sodium, are able to pass through the lining of these capillaries. They move across the basement membrane, through the epithelial lining of the nephron, and finally into the space in the nephron itself. So this is called the glomerulus. This is the capsule, or Bowman's capsule. And here's the space where the blood surround. Okay, the blood flows into the glomerulus, as I was saying, water and solutes in the blood, like sodium, are able to pass through the lining. They move across into Bowman's capsule in the space of the nephron itself. We call stuff that comes out of here filtrated. So blood came in. What wasn't useful was filtered out here. The regular blood, which red blood cells and some certain things will not get filtered out, they continue along. All this stuff that came out goes in here to the proximal convoluted tubule. We call this stuff filtrated. It's not urine yet. So the renal capsule, here's another look at it. We have the capsular space. These are the podocyte cells. They call them that because they mean feet, and they kind of look like the tentacles of a octopus. And this is what happens to the filtrate. Okay, the blood comes in, goes through here, and the filtrate comes out into the proximal convoluted tubule. There's a close-up of the podocyte cell, which is a pretty good sieve. It takes all the ingredients to the filtrates, filtration slits. So here we have the tubules again. We have the proximal convoluted tubule. It's convoluted because it's all over the place. It's all convoluted. And it is proximal because this one is very close and comes right out of the glomerulus. And it comes through here, goes down through the tubule system. And this is called the loop, also known as the loop of Henle. Okay? This is the descending limb and the ascending. This is the descending limb, this is the ascending limb of the loop of Henle. And this is the proximal convoluted tubule. This being on the other side is called the distal convoluted tubule. And it empties into the collecting duct. And the collecting duct will empty into the calyxes inside the kidney and be sent out as urine. Okay. Here the filtrate that came out of here is starting to get fine-tuned based on what the body wants to do, versus what it wants to discard. Water and solutes are getting passed back and forth between the filtrate and the lumen of the renal tubule and the blood in the again, we have the renal corpuscle, the proximal convoluted tubule, the descending limb of the nephron loop or the loop of Henle, the ascending limb, and we're going up to the distal convoluted tubule and ultimately into the collecting duct, which will primarily end up going out as urine. Okay? So again, I said the body fine-tunes everything. It's not sure what it wants to do. So it's going to reuse anything it has. So this filtrate's coming down through here in the descending loop of Henle, and we're going to let the water come through. And we're going to go into the ascending limb, and we're going to get rid of sodium. Okay, we're going to have urea come in. We don't like urea, so we've taken urea from some of the other tissues, and we're going to send that out, out into the urine, into the renal pelvis. You'll see there's more water that can be done. So anything that can be reused is reused. Here's an example. We have the cortical radiate arteries, the afferent arteriole coming into the glomerular tuft of capillaries. What is filtered out ends up coming down as filtration or filtrate. The rest of it continued on through the efferent arteriole into the proximal tube, and it's coming down to go out to the veins. However, the body may be in a condition that says, wait a minute, I really don't want to get rid of all that stuff. I want to send some of it back in. So there's tubular secretion, sends it back into the, or, well, in this case, it decided it didn't want to keep it, so it sent it back in to be discarded as urine. And some of this filtrate is coming down. The body said, whoa, I need some of that stuff, so let's send it back in into the system so we can reuse that. All right. So each nephron also has a unique region called the juxtaglomerular complex. This regulates our blood pressure and the glomerular filtration rate, or how much blood passes through this thing. Okay? It's located between the distal convoluted tubule and the afferent arteriole. This is up here, distal convoluted tubule. Okay. There's three types of cells in the juxtaglomerular complex, or the JGC, it's referred to. We have macula densa cells, which are these guys here. We have juxtaglomerular cells, which are these guys here. And we have granular cells, which are part of the mesangial cells on the outside of that. The function of these guys is to sense the levels of sodium and chloride if they're low. If your blood is too low or you don't have low blood pressure, these macula densa cells will sense this. And they will send a signal over to the other cells in the wall of the afferent arteriole, these guys here. And the signaling of these cells will tell them to release an enzyme called renin. Renin increases sodium absorption. It helps raise the blood volume. Renin also causes constriction of blood vessels, which helps raise the blood pressure. However, if you have your blood pressure is too high already, you'll probably take medication that would interrupt that renin complex. So after it kind of comes through here between the proximal convoluted tubule, it's going to end up going down the ureter. So millions of nephrons have each made urine, and it flows into those minor calyces, then the major, then finally into the renal pelvis. From there it goes into the ureter. So we can see all these collections here. This is the veins, and the nephrons are all up in here, millions of them. And they do that little filtration thing, and they're going to come down into here and disperse the urine into the minor, the major, the pelvis, and out the ureter. Okay. So it goes down that ureter, which has a muscular lining, helps to push the urine along. The bladder itself is like a balloon. It has many folds in its muscular wall. We call them rugae. Somewhere these are rugae. They're like the musculature we saw inside the heart. Okay. So these rugae can contract when the bladder is emptied of urine and can expand when it's filled. So in the layer of the bladder wall, there's a mucosal layer that has transitional epithelia. Remember, our transitional cells is the only place we find them. Another area that's important is this area we call the trigone area. It's a pyramid, so it has three areas. It's very sensitive to expansion, and once it stretches to a certain point, the bladder will send a signal to the brain. It's time to pee. So the urethra is a thin muscular tube that drains urine from the bladder. The urethra is here in the female, and it starts here in the male, which is certainly much longer. In males, the urethra first passes through the prostate gland. We'll look at this more in reproduction. This is the prostate gland. So the urethra comes through this, and what it does is referred to as the prostatic urethra. Okay? Then it passes through the deep muscles of the peritoneum, which are kind of like right here, this little tiny space right here. Okay, this is called the intermediate part of the urethra, or the intermediate urethra. And it finally passes through the penis, where it's called the spongy urethra. This area is the spongy urethra. Spongy, intermediate, prostate. Females just have a urethra. Okay, so the male urethra is used during ejaculation. Semen enters the urethra via the ejaculatory ducts. They're not listed here. We'll talk about that in reproduction. Okay. So there is an external and involuntary sphincter that controls the level, the external urethral orifice. We have the internal urethral orifice, and we have the external urethral sphincter. We have an internal urethral sphincter. A sphincter is a closing or an opening, kind of like a camera shutter. So the involuntary sphincter is controlled by the autonomic nervous system and keeps the urethra closed when the bladder isn't full. There's also an external sphincter, which is under voluntary control. So by contracting the skeletal muscle around the sphincter, urination can be stopped voluntarily. And that ends our discussion today on the kidney.